Welcome to Summarize Science. Today we are exploring a cutting-edge study from researchers at Johns Hopkins University. They wanted to know if AI coding agents can actually reproduce complex findings in materials science. This is a huge deal because scientific progress depends on other researchers being able to verify results. They created a new benchmark called AUTOMAT to put these AI models to the test. The benchmark uses 85 real-world claims taken from recent scientific publications. Many AI models are already great at general software engineering tasks. However, scientific reproduction is a different beast because it involves underspecified and tool-rich environments. To mimic a real scientist, the AI agents are given a task package containing the research paper and associated data. The AI then has to plan an investigation, execute commands, and write a final report. The researchers categorized these claims into different types, like scalar metric matches or figure reproductions. Some tasks required the AI to work from the paper alone, which is much harder than having the original code. When the results came in, the researchers found that even the most advanced models struggled. As shown in this chart, the highest average score was only 3.52 out of 5. The best-performing agent setting only had a success rate of about 54%. There is a massive performance gap depending on what information the AI starts with. Tasks that required reading the paper and starting from scratch had near zero success rates across all systems. By contrast, having access to existing code and artifacts made the job significantly easier. Looking at this failure mode heat map, we can see exactly where the AI agents went wrong. The most common issues were procedural incompleteness and methodological deviations. Basically, the AI would either skip important steps or try to solve the problem using the wrong scientific approach. In a specific case study, an AI agent correctly identified a mismatch in the data but failed to translate that diagnosis into a working solution. This shows that while the AI might understand the problem, it cannot always execute the fix. Another example showed an AI getting the right answer but for the wrong reasons. It matched a specific accuracy number by essentially fishing through the data until it found a combination that worked. To recap, this study reveals that AI is not yet a reliable autonomous assistant for scientific research. It lacks the ability to navigate the subtle, implicit choices that human scientists make every day. However, these findings provide a valuable diagnostic tool for the future of AI in science. By identifying these limitations, researchers can now work on building agents that prioritize scientific rigor over just finding a good-looking result. Improving these systems could eventually lead to a world where AI helps us verify and discover new materials at lightning speed.